This topic is so fun. Higher order derivatives are not usually that difficult to find because the functions that you're asked to use are usually just simple polynomials like this one. Higher order derivatives, I'm not really teaching you anything new other than notation in this video, and so you could probably do this on your own without this example. If you feel confident finding the first four derivatives of this guy, meaning just keep finding derivatives 4 times, go ahead, pause the video, and then fast forward a little bit to see if you did it right. If you don't feel up to that challenge, let's go through this together. We have y equals this big thing, and we just want to keep going. So I want to first find y prime, that's our first derivative. I'm going to use the power rule for each one of these first 4 terms and just find the derivative of each term. So I'm going to bring that 5 down, multiply it by the -1, raise it to 1 less. Over here, we'll bring that 4 out front, multiply it by the 2 that's already there, 1 less. This is a 1/3 x cubed, so I bring the 3 out, multiply it by 1/3 and get 1. So I have 1x squared. Here I bring the 2 out front, and the derivative of a constant is 0, so I don't put plus anything. Okay, I did my first derivative. That's pretty cool. So 1. Then let's do our second derivative, y double prime. And I'm just going to find the derivative of y prime. So again, using the power rule here on each one of these terms, we'll have -20 x cubed plus 24 x squared plus 2x minus 2. That was the second derivative. Moving on to the third derivative, y triple prime, triple threat. We have -60 x squared using the power rule. See how important the power rule is? It's used all the time in calc. And then the -2 disappears because it was a constant, so its derivative is 0. Our fourth derivative, and any derivatives above 4 and above, we don't use little tick marks because that would get insane. So instead we put in parentheses what type of derivative we're taking. And I'll also show you some more notation in just a second. But we're not doing anything differently here. Again, using the power rule on each one of these. So -120x plus 48. That is pretty cool. So we found, that's not even the answer. Our answer is all of these. We found the first 4 derivatives, 1, 2, 3, 4, and not anything new. Let's take a look at some notation on the next slide. Here is some notation for higher order derivatives. The most common one, really we're rarely going to see the one in white down here. Your book does use the tick marks and the dy dx together, so that's the only reason I'm really putting this here. I've rarely seen that in other math texts. The ones that we'll most commonly use are in blue. And then I just want you to understand the dy dx and then where the 2's, the 3's, and the 4's are. Again, rarely will we hit a fourth derivative. It's normally only going up to the third derivative in math, which we'll see why in a little bit. But just so you understand the notation here. Now, are you curious why the 2 is next to the d in the numerator, but the 2 is next to the x in the denominator, same with the 3 and the 4? This is pretty cool if you're interested. What we're doing is, to get from the first derivative from the second derivative, we're taking the derivative of dy dx. So we are taking d dx, the derivative of dy dx, and mathematically, if we were to multiply across, we have d squared y, and then the dx is squared. So that is why the 2, the 3, and the 4 are in the places that they are, if you are curious. If you do not have to know that or have it written down, I just was always curious about that, and so that was something I'd like to share with you. All right, so higher order derivatives are not the craziest idea. It is just finding derivatives of derivatives.